Recording. Okay, cool. So a crucial difference between currying and decorators. So you can use, okay, let's do, so currying is going to be like take one function and make multiple more specific functions out of it. Decorators is going to be like applying one modification to multiple functions. So let me see if let me try coming up with an example for decorators. Let's say, hypothetically, every single time that you run a function, like any function, let's say hypothetical, whenever you run, let's say whenever you run, candy store transaction, you want to say hello and goodbye, like before and after you run. But not just candy store transaction. You want to do this for a bunch of functions. So that would mean ordinarily we're going to hard code print hello and print goodbye into every single function that we write. And this could be like one function. This could be like 15. In either case, that sounds absolutely terrible. So let's see if we can avoid that, which is thankfully where decorators can come in handy. So a decorator is a function that you can apply on top of another function, basically. So the way that we use decorators is we take a function as an input to our function. It sounds really awkward, but that's how we use it. So let's say, define, let's say, greetings decorator. And we're going to take in some function that we're going to do this, around. And then inside it, we're going to define a wrapper function that we call our function user. So let's call this define like inner wrapper. And then any function that we write, it has arguments and optional arguments. So it's going to take in args and quargs, which is again, arguments and keyword arguments. And the first thing that we need to do is print out hello. So we'll print hello. Then we need to actually run our function. So we're going to say func and then args and quargs and let it do its merry business. And then we're going to print goodbye. And is there anything else we should do? We don't need to return anything in here, but we do need to actually return our inner wrapper function. This is what a decorator looks like. It is very ugly. Like, trust me, this syntax is not pretty, but we can apply it to any function we want. So, let me just define like add two numbers, and we'll just say like n1, n2, and then we'll just like return n1 plus n2, like super simple. So what I can do is I can say at greetings decorator right above that. And then we can print out, add two numbers like 12 and 34. So what is this doing? First, let's make sure it works. Okay, we should probably take out some of these print statements because those really are not needed. And let's run that again. Perfect. Okay. So when we add in, here, let me also just do print n1 plus n2. There we go. That should look a little bit better. And we won't print this out. See that? Great. So when I run this, what should happen, ideally, is add two numbers gets input into our decorator. So greetings decorator takes in some function as an input. That function is add two numbers. Okay, great. What do we do from there? Now, add two numbers takes in two inputs. It takes in 12 and 34, n1 and n2. Those are our arguments. So consequently, our inner wrapper function also takes in those two are those arguments of n1 and n2. Inner wrapper function will print hello. So let's run it, and it prints hello. Then it runs whatever function we decorated. What's the function we decorated? Add two numbers. And it inputs whatever arguments we gave it. What arguments do we give it? n1 and n2. All right, 12 and 34. So it'll add them, and it'll run the original add two numbers function. And it prints it, and then it returns the values. And then it's going to print goodbye. And we see it prints goodbye. That's the gist of how a decorator works. If you want to run something around another function, or like decorate its behavior, use a decorator. Decorators are used very frequently for timing events. I would show you guys how to do that, except that's part of your homework for tonight. So I'll be interested to see how you guys decided to approach that after doing the homework, because there's a few ways of doing it. But this is the gist of how a decorator works. So like, you take in your function, you take in your wrapper that takes in the arguments, you say, do stuff before calling the function, you input, then call the function, and then do stuff after you called the function. It's a little awkward, not the prettiest, but the main use I've found for it is going to be in testing and timing your functions. Because trust me, you really want to have a good way to know whether a function you use is going to take a millisecond to run or 3 seconds to run. Or, there's a big difference if you're running a function on like millions of times or on really big data sets. There's a difference between the function taking half a millisecond to run each time or 1 millisecond to run each time. It sounds like a small difference for us normal humans, but if you multiply that number by like 1,000 or a bigger number, those add up. So decorators, I found, are really mostly helpful for timing things. I think there is an example in the curriculum for today. Let me see if I can find that real quick. One, there we go. Hopefully, can you guys see my browser now with the curriculum page? Okay, cool. So for the decorators example they use, which is also a little bit complicated because it's a decorator, is for running a function one time and one time only. So let's break it down. Let's see how it works. So function called once, it takes in any function. It doesn't matter what your function is. It takes in some random function. Then it defines a variable called false. Or, well, it defines a variable named called, which is equal to false. And then we have that inner wrapper function. The inner wrapper function takes in whatever arguments were in that original function. So like for cell is going to be the input to once, but the args part of inner is going to be asset ID and value. So then what it's going to do is it's going to check, hey, I have a non-local variable called called. If has called been set? If called has not been set, then I'm going to say the function was called, and I'm going to return the function. However, if it was called, if this value is true, then I'm going to raise an exception that says you can only call this function one time. So the entire way, this is kind of similar to currying in that you're nesting a function within a function. But the crucial difference that I'd like for you guys to know is, number one, for decorators, have a nice little bit of syntactic sugar, is what we call it. Basically, like a slightly more elegant way to wrap a function in a decorator, whereas currying, it's a little bit more cumbersome to use or look at. The second thing is, again, decorators and currying follow very similar formats. Decorators have behavior that needs to be run before or after you run a function, or around when you run a function. And it needs to take in the arguments to your original function. And lastly, whereas currying, the benefit of using currying is to have one function have multiple variants or subtypes. For decorator, you can use that decorator on multiple functions that are different. That's about it for the currying and decorators lecture. Let me just go through the page and double check everything. So we have currying up here. They've got an example with zero padding that I recommend. And this is what we were talking about. So you can create many subclasses or specialized versions of your original function for whatever inputs you want. Nice and simple. And then decorators kind of work the other way. We talked about syntactic sugar. We talked about an example of how to use them. That's about it for lecture. So I'm going to go ahead and